We just learned how to make a confidence interval for the difference of two proportions, and now we're going to do a hypothesis test. So just as before, we're going to have a null hypothesis and alternative hypothesis. Now keep in mind that we're finding the difference of two proportions, and what we're assuming is that the difference of the two proportions is that there is no difference, which means that when I subtract them, I get 0. Now I do want to point out that I will always write my null and alternative as a difference. You might also see this written as P1 equals P2 so that the two proportions are equal. But for my purposes or for any of your case studies that you do for me, you're going to want to make sure you write them as differences. And again, equal to 0 because that's what we expect the difference to be. We are hypothesizing that there's no difference, which means that the P1 and P2 should be equal, which means we're going to pool our results, and that is going to be our P hat pooled, or some you will just see it as P hat as opposed to P hat with a subscript. Which means for hypothesis testing only, when we're doing our standard error, we're going to be using our pooled data. So our P hat pooled and our Q hat pooled over N, and P hat pooled, Q hat pooled over the other N. So these values will be the same, and these values will be the same, and these of course will be whatever the numbers are in each of those samples. Just as before, we're using the same concepts as whether we reject or fail to reject. We're still going to use 0.05 unless we're in a situation like we will be here in a little bit where we are deciding what level we should be using based on the level of confidence that we have done. We're going to find our z-score, and then remember our z-score is our observed, this is our observed minus expected. So there should be a -0 in there. So the -0 seems a little silly, but you should have a -0 because our observed is the difference between the two proportions. Our expected is that the difference should be 0. And then our standard deviation or standard error is based on pooled data. Again, our null hypothesis is that we assume the proportions are equal, so P1 minus P2 equals 0. And then our alternative will, of course, just be based on the context of the question, that the difference is greater than 0, meaning that P1 is bigger, that the difference is less than 0, meaning P2 is larger, that the difference is not equal to 0, meaning we don't know which one is larger, but we just are testing to see if it's not the proposed hypothesis of 0. So let's do a practice together. Now this should look familiar to you because you should have already watched the video on confidence intervals. Notice this is the same question that we did before, and the question itself says, would being part of a support group that meets regularly help people who are wearing a nicotine patch actually quit smoking? So essentially we're saying, if they're in this group, will they quit at a higher rate than people who don't go to this meeting? Which means our test will be one-tailed because it's going to be a greater than. So the difference is going to be greater than 0 because that P1, the people who go to the group, should hopefully quit at a higher rate. Okay, so recall we checked our conditions, so we're going to perform a 2-proportion z-test. It's still the normal model. Also recall that we did a 90% confidence interval previously, and this was our result. So based on that result alone, without even having done the test yet, I should know that I will be rejecting the null hypothesis. And I know that because my proposed value, which of course is going to be 0, not in this interval. Okay, because 0 is not in the interval, then we know that we should be rejecting because there's obviously a difference. But of course we're going to do the test anyway so we can practice. To keep the same level of confidence, we learned about this last week, we know that we're going to find alpha, which is 100 minus the confidence level over 2. We did 90% confidence, 100 minus 90 over 2, so we're using that 5%. So again, remember we divided by 2 since our test is one-tailed. So again, the hypotheses, the first one is that when I subtract, the proportion is going to be equal to 0. So that's there's no difference in a quit rate between those attending meetings and those who don't. And then our alternative is greater than, and I knew it was greater than based on this very first sentence where it says that it's going to help them to quit smoking. Now, for our calculations, again, I'm going to show you by hand, but I'm going to really expect you to be able to do this in StatCrunch. By hand, I would first find the pooled hypotheses. Now remember that these numbers, 45.76 and 30.2, I got by taking my group 1, 143 times 0.32, so that's where this came from, 143 times 0.32, and this one was 151 times 0.2. That's where I got both of those values. So that is my p-hat pooled, and I needed that because I needed that for my standard error. So again, here's all my calculations by hand. I found the z-score, which is the 0.32 minus 0.2 minus 0 over the pooled standard error, 2.35. I used technology to find the probability that z was greater than 2.35 and got this value. So let's look at what that is in StatCrunch. So in StatCrunch, I'm going to go to Stat, and again, we're still dealing with proportion stats, and it's 2 samples with a summary. Again, I really want to use the most exact value, so do not round 45.76 to 46, or your answer will be off. So I'm going to put in 45.76 over 143. For the next, it's 30.2 over 151. And remember that for my hypothesis test, the first one should be 0. The alternative in this case was greater than, because I was saying that the rate of people in group 1 would be greater than the rate of people in group 2, or that the difference would be greater than 0. And then I'll compute. And notice it gives me that same value of 0.0094, which is essentially what I have over here. My conclusion, again, I have to compare it to the correct alpha level. In this case, it was 0.05, so it's very low. We'll reject the null. There's evidence to support that people quit smoking at a higher rate with a support group than those who don't attend support group. And then notice I'm tying in that confidence interval conclusion. I'm saying I'm 90% confident that between 3.6 and 20.4 more smokers will quit smoking by attending the weekly meeting. Here's one for you to try on your own. Notice we've already checked the conditions in our last video, so you don't need to do that. And I don't need for you to do the calculations by hand. I just need you to do that in StatCrunch, and then please write your conclusion and include the results previously from your confidence interval. So in StatCrunch, I'm going to go to Stat and then Proportion Stats, 2 sample with summary. Again, when I'm putting in the number of successes, please don't put the 0.28 and the 0.14, but I should be taking 0.28 multiplied by 506 and 0.14 multiplied by 520. Now again, with my hypothesis test, my null hypothesis is always that it's equal to 0 when I'm dealing with 2 samples. My alternative here would be what? Well, let's take a look. We're saying, who do we think is more intelligent? Is there a gender gap? Is there a gender gap means we don't know which one is greater, so that's going to be that not equal to, and then I'm going to compute. So again, the not equal to is our alternative hypothesis. Here's all of the values that you would compute by hand. I'll leave that up for you to look at. But again, over here in StatCrunch, it has found the sample difference of 0.14, which is of course taking that 0.28 minus 0.14 to get 0.14. Found the z-stat of 5.514, which is what I found by hand. Found the p-value of less than 0.0001, which means it's essentially 0. Now notice, yes, I've taken whatever value I had and I multiplied it by 2 since it was 2-tailed, but it doesn't matter because that value is so small that it's still essentially 0. Again, our result is that we would reject the null. There's evidence to support that the proportion of men who believe men are smarter is greater than the proportion of women who believe men are smarter. And then I'm tying in my confidence interval. I'm 95% confident that between 9.1 and 18.9% more men feel men are more intelligent than women who feel men are more intelligent.